Hi guys, today we're going to work on the distance formula. And the distance formula is exactly what it sounds like. We're just looking for the distance between 2 points on the coordinate plane. And just like with most things in math, there's a formula to do that. So the distance formula can be used to find the distance between 2 points on the coordinate grid. And the 2 points that we're looking at in this case are, this is the first point, which is x1 and y1. This is the second point, which is x2 and y2. And there's variables in there so we can see how those variables go in the distance formula equation. These little subscripts down here, these ones, the x1, y1, and on the x here, the 2 and the 2, they're just identifiers to identify the location on the coordinate grid that we're talking about. So they have no mathematical purpose. The only purpose for those is to identify which points you're referring to as the first points and which points you're referring to as the second. It's kind of like when you go to a stadium and you have a seat number and a seat ticket. You go to row D number 21, so you know. So this is like saying we're going to row 1 or we're going to row 2. They just happen to be points. So the subscripts just refer to the first and second points. It doesn't matter which one you call the first and second. The x1 and the y1 are xy coordinates for point 1. The x2 and the y2 are the xy coordinates for the second point, or for point 2. And D will give us the distance between those 2 points. And here's the formula. You take the difference of the x values, x2 minus x1, you square it. You take the difference of the y values, y2 minus y1, and you square it. You add those two together, and then you take the square root to find the distance. So let's take a look at problem number 1. Find the distance between point T, which is 5, 2, and point R, negative 4, negative 1, and round your answer to the nearest tenth. So the first point is point T, and that's 5, 2, and we're going to use this for our first point. We're going to call this x1 and y1. And then point R is negative 4, negative 1. We're going to use that as our second point, so we'll call that x2, and we'll call this y2. And then we're just going to plug it in the formula. So the distance formula, we are going to take x2 minus x1. x2 is negative 4. x1 is 5. We're going to square it, and we're going to add it to the difference, the square of the difference of the y values. So y2 is negative 1, and y1 is 2. And when we simplify what's in those parentheses, negative 4 minus 5 is negative 9, and we have to square it. Negative 1 minus 2 is negative 3, and we have to square that. So again, we need to simplify what's inside that radical sign. Negative 9 squared is 81. Negative 3 squared is 9. When we add 81 and 9, we get 90. And when we take the square root of 90, we get a number that is really close to 9.5. And you can use your calculator for that. So the distance between these 2 points on the coordinate grid is 9.5. And if the coordinate grid is in inches, it would be 9.5 inches. If it was in centimeters, it would be the same thing. So go ahead and try problem number 2. AB has endpoints of A, which are 1, negative 2, and B, which are negative 4 and 4. We need to find the length of AB to the nearest tenth. So this is where you might want to pause the video, work out the problem on your own, and then start the video again and you can check your answer. So I'm going to go ahead and identify point A as my first point. And so that's 1, negative 2. So x1 is going to be 1 and y1 is going to be 2. And my second point, negative 4, 4. My x2 value is negative 4. And my y2 value is positive 4. I'm going to plug it in the distance formula. I'm going to subtract my x values, -4 minus 1, I'm going to square it. I'm going to subtract my y values, which is 4 minus -2, and I'm going to square it. Simplify what's in the parentheses. I get -5 squared plus 6 squared. And squaring will take care of that negative inside the parentheses. -5 squared is 25. 6 squared is 36. 25 plus 36 is 61. And when I take the square root of 61 on my calculator, it's about 7.8. So check your answer, see if you did it correctly. And we're going to work on this a lot more in class tomorrow. And so let's go back to the notes here. The important thing is that you memorize the distance formula, which is right here. Distance is the square root of the difference of the x values squared plus the difference of the y values squared. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so that you can remember the distance formula, here's a little song to memorize the distance formula. And I'm going to sing it for you. I'm not the best singer in the world, but I'm going to try. So when finding the distance between 2 points, subtract both the x's and then both the y's. Square both these numbers and then find their sum. And then take the square root and you will be done. The first person in each class period who sings that for me tomorrow will get a prize. Okay, now it's your turn to answer multiple choice question number 1. Use the distance formula to find the distance between point C and point D. Make sure you round your answer to the nearest tenth. And the free response, and we're gonna explore that some more tomorrow. Is there another way to find the distance between 2 points without using the distance formula? So think about the shape you could create using these 2 points on a graph. Make sure you go to the Google form and put in your answer for multiple choice question number 1, multiple choice question number 2, and again, the first person in each class period who sings me the distance formula song will win a prize, probably a piece of candy or something really cool like that. Okay, have a good night. We'll see you tomorrow.